Let us understand about left or right outer join using Spark, especially with the Dataframe APIs. Many times we want to get the data from both the datasets satisfying the join condition along with the data from the driving table which does not satisfy the join condition. In those scenarios, either we can use left outer join or right outer join. Based upon the side of the driving table, we define it as a particular type of outer join. If the driving table is on the left side, we call it as left outer join. If the driving table is on the right side, we call it as right outer join. Here is one of the classic example with respect to outer join. It is nothing but we have customers data in customers folder or table and orders data in orders folder or table. There is one-to-many relationship between customers and orders. One customer can place as many orders as he want in his lifetime. There might be customers who never placed any orders. Those are also called as dormant customers. We might want to get the revenue or number of orders placed by customers. In case if we need to display count or revenue as 0 for such customers who doesn't place any orders, we need to perform outer join between customers and orders with customers as the driving table. Let's get into the demo so that you understand the details. This will take care of starting the Spark session for you. The object name which contains Spark session is nothing but Spark. Using that, we are setting this property called as Spark SQL Shuffle Partitions to 2 so that it doesn't use too much of resources to take care of join because we are dealing with a very small dataset. This will take care of reading orders dataset into a data frame called as orders. This will take care of reading customers dataset into a data frame called as customers. You can review the schema for orders as well as customers here. Orders have these 4 fields, customers have these many fields. Let's review the help on customers.join. So we have to invoke join using a data frame. This is data frame, and then there is a function called as join exposed to the data frame. You can get the help on dataframe.join like this. You can see that you can pass other data frame as first argument, and then you can actually pass the condition using keyword argument called as on. Then you have to pass the type of join using how. It can be inner, it can be left, it can be right, it can be left outer, it can be right outer, it can be outer. There are n number of types with respect to joins. Depending upon the type of join you want to use, you can pass appropriate value here. Default is inner. In our case, depending upon the position of the driving table, we have to specify left or right or left outer or right outer to take care of left outer join or right outer join. As customers is the driving table, because we have one-to-many relationship between customers and orders, we have to specify left in this case. If you are using join on top of orders, which is child table to customers, as customers is the driving table, and as we are passing customers as argument in that scenario, as part of how, we have to pass either right or right outer to take care of appropriate outer join between orders and customers. In mind that when you want to perform left or right outer join, the driving table position will determine the how. How should be passed based upon the driving table position. Let's get into a few examples here. This is an example for inner join. If you actually see the syntax as part of how we are using inner, it will actually return only those orders which satisfy the condition, which is nothing but this one. You can see that orders have 68,883. Each and every order is associated with the customer, and hence we are getting 68,883. There might be few records only in customers but not in orders. They are not part of this count. Now, if you want to get the count of all the customers, whether the orders are placed by them or not, you should be performing the outer join. It can be either left or right. As customers is the driving table in this scenario, as we are invoking join on top of customers, as part of how, we have to pass left like this. You can see the syntax. Either you can actually specify left for how or left outer for how. Both are same. You should be able to preview the schema by running this. You can see that all the columns related to customers came first and then orders, because we are performing left outer join between customers and orders. You can also see the count. Earlier we have seen that orders have 68,883. Even the inner join results count is nothing but 68,883. But now it is 68,913. You can see there is a spike in the count. There are 30 customers who haven't placed the orders between 2013 July and 2014 July, as we have the data for the date range in our sample dataset. You can also use right outer join to solve the same problem. However, the driving table has to be passed as the argument to the join, which is called over other data frame, which is nothing but orders. As customers is on the right side, you can use how equal to right or how equal to right outer. Both will be the same. Now you can see the count with respect to right. We got the same count. However, when it comes to schema, we got the order level details first and then customer level details. That is the reason why I have mentioned that as long as you don't use star, the results will be the same after joining the datasets. Just keep that in mind. That being said, now let's say I want to preview the data, I can preview the data like this. This is the customer order details left data frame, which is nothing but this one. This is the logic which is used to build this data frame. If you want to project some of the fields, you can project the fields like this. If you want to get some of the fields from customers, you can specify the fields like this. As I want to get all the fields related to orders, I am saying orders of star like this. You can see the customer ID, email, and also the other details from the order. They are nothing but order customer ID, order date, order ID, and order status. You can preview the data like this on top of data frame which is created because of the join. You can also get count from orders and customers. Orders have 68,083 records. Customers have 12,435 records. Customer order details, which is nothing but inner join between the two, have 68,883, whereas left outer join returns 68,913 records, which means there are 30 additional records in customers who never placed orders in their lifetime. Now, using customer order details left, let's get all the customers who never placed orders. We need to check if order's primary key is null on the left or right outer join results. This is how you can add additional condition on the data frame called as customer order details left to check whether order ID is null or not. So in this case, we are only getting those customer details who never placed orders in their lifetime. You can see the output here. I am projecting only customer ID, email, and the details from orders. All the details related to orders are nulls here, whereas with respect to customer ID and customer email, we can see the details. Now, it is very important to determine what field should be used to get those records which are not there as part of the child table, but they're on the parent table. We should be typically using primary key field from the child table or foreign key field as long as it is not nullable column. If it is a not nullable column, then you should be using only the primary key field. In this case, either you can use order ID or customer ID. However, if customer ID is nullable, you should not be using customer ID. You should always use order ID to filter for those records which are not there in the child table, but they're in the parent table. These are some of the sample records. You can also get the count here. We have 30 such customers who never placed orders in their lifetime. You can also use aliases like this and get the same results. Same logic is implemented in a alternative way. I have defined aliases for both the data frames and used aliases for filtering as well as selecting using select expression. You can use either of the approach. Whatever is convenient to you, you can stick to it. You can also get the count using alternative approach. We have 30 such records. Now let's get the number of orders placed by each customer for the year 2013. If a customer have not placed any order, get the order count for the customer as 0. This is further transformation after joining the data. Here is the orders data frame. Here is the customers data frame. I am filtering for the year 2013. So orders underscore filtered is a data frame which contain only 2013 orders. Now with respect to join, as customers is the driving table, and as we are using join on top of customers, I am using left as part of how. Rest of the logic is same. You should be able to get the count for orders underscore filtered. We have 30,662 orders that are placed in the year 2013. With respect to customer order details left, which is nothing but left outer join between customers and orders filtered, we are getting 31,746 records, which means there are more than 1,000 customers who haven't placed any orders in the year 2013. Let's review the help on customers.join. So we have to invoke join using a data frame. This is data frame, and then there is a function called as join exposed to the data frame. You can get the help on dataframe.join like this. You can see that you can pass other data frame as first argument, and then you can actually pass the condition using keyword argument called as on. Then you have to pass the type of join using how. It can be inner, it can be left, it can be right, it can be left outer, it can be right outer, it can be outer. There are n number of types with respect to joins. Depending upon the type of join you want to use, you can pass appropriate value here. Default is inner. In our case, depending upon the position of the driving table, we have to specify left or left outer or right outer to take care of left outer join or right outer join. As customers is the driving table, because we have one-to-many relationship between customers and orders, we have to specify left in this case. If you are using join on top of orders, which is child table to customers, as customers is the driving table, and as we are passing customers as argument in that scenario, as part of how, we have to pass either right or right outer to take care of appropriate outer join between orders and customers. Depending upon the driving table and its position,